Hi, class. Look, I apologize immensely. I did not record the first hour. So I'm going to take like 5 minutes and go through this. But I think if you just look through the slides, you'll be fine. Basically, what I'm trying to do is go through the aspect of understanding the context of system engineering. And in order to do that, I actually use the system engineering handbook, which is actually kind of the basis for the NCOSE System Engineering Professional exam. And we went through the context where we actually talk where technical processes are Chapter 4, management processes are Chapter 5, the agreement or contract, Chapter 6. Chapter 7 is your project enabling processes from the organization. I'm going to go inside out, start with Chapter 7, actually get into life cycle model and get into the performance and all. So basically, it all uses this IDEF IPO diagram, input, activities, and or processes and output. The first thing I start was life cycle model. That actually defines your life cycle model process that you would use that actually describes everything you do for the processes that are on. So, Precious, hey, how you doing? I'm here trying to repeat a little bit until everybody gets on what I didn't record. So I'm recording so right now. All right, the life cycle is ordered to do all the processes that are on top of the model itself. Your output, you establish, assess that project and process, and actually put it through that way, and actually improve the process as you go along. On top of that, you have your portfolio management process. That's basically putting all the processes together, all the projects together. Think of a portfolio organization is one organization, but it has multiple projects that you would work. So this is just to establish your portfolio, manage all the projects you would be in place. Inside of that would be the idea of tailoring the processes for each of those projects, as well as for the organization. And that's what the tailoring process does. Actually makes sure your life cycle model processes are necessary and that they add value to the organization in the project. The other thing is quality management. That looks at both the quality of the processes that are in place and the product or system that is the output of all the processes and as they go along. The fourth thing is the actual infrastructure. We're actually trying to make that work where you actually have to have an enabler to help your processes. The infrastructure provides you with like the IT or the facilities in order to be able to work the processes. So that's what the idea of infrastructure management is all about. Then we have knowledge management. Basically, you're just trying to capture what's actually out there and working. Hi guys, I'm trying to record. I'm trying to record what I did not record just for that hour. For those of you who want to watch this later on. So we'll get started in about 3 minutes. Let me finish this up real quick. If you don't mind listening, you probably can go to the restroom now and come back and I'll finish. All right, knowledge management. You're trying to catch those lessons learned in order to improve your process as well as to be able to repeat the processes so that you can actually redo and create the systems that you've created in the past. Human resource management, exactly what it says. It actually does human resources. Make sure you have the people that do the processes are in place. From there, you plan, you actually develop a contract through acquisition. Somebody would come to you and say, I need a product or service. And then from a supplier standpoint, on the other side, would say, hey, I'll provide that to you. So this process actually enables you to actually put a project in place and actually start working and planning that process. Part of planning the process is actually getting all these strategy documents in place. Project assessment and controls looks at the plans that you put together in project planning, and it assesses and controls the project once the project is activated. And then on top of that, you have measurement. What are the actual measurements of both collecting data and information that supports the actual aspects of not only the processes that are in place, but also the product itself through the MOEs, MOPs, and TPMs. On top of that is decisions. Of course, you have to understand decision requires analyzing the various objectives or alternatives that are in place, and then figuring out which is the best way to go. You plan that before you even make a decision, and if a decision comes up, you incorporate the process in instantiation. Risk, of course, is the opposite of the opportunity that the project is doing, and you actually manage the risk looking at all your threats. All right. And we just finished class 1 exercise where we actually create an IDEF diagram. We're going to see what they've come up with. There's still people not here yet. So I'm going to go on hold for a little bit and mute as we wait for the teams to come and join us. All right, guys. Let's see who's here. All right, good. It looks like there's a team or two. Team one is still taking its time. Jordan just left. I don't know why. Yeah, sometimes I've noticed some students, they have to quit and then come back in order to try to be able to see again. All right, guys, can you, am I sharing? I have to share. Okay, Alden, you have your hand raised. Did you want to ask me some?
Yes. I was like pulling my hair out about what type of diagram this is. This is similar to a component, or what type of kind of like relevant or like similarity. There we go. It's similar to a component diagram, correct?
Component diagram?
Yes.
I'm not familiar with that.
From SysML and SM and this is Sys, yeah, 663. Yeah, so it's a SysML model. So like use case diagrams, class diagrams. There's activity
Correct. Is there an
sequence.
activity diagram?
Yeah, activity sequence state. But one of components not used as much. I'm a systems engineer as well, but we don't use it as much. But we used it in class with 662. So I used to like mess with it a lot, and it seems very similar. I was just curious if you knew um, something about it, but I know it's not used that frequently at all.
No, no, not. Activity diagram, your input,
Yeah,
activity, your output, right? So it's very straightforward, IPO, right? So it's input, process, output. It's not much, not very difficult, right?
seems like a component. Look into component. I think it's the same thing.
Yeah, whatever it is, as long as you understand what your processes are
Yep.
doing, that's the important part.
Roger that.
All right, good. Thanks, Alden. Appreciate it. All
Thank you.
right. Looks like everybody's back. Let's go ahead and pull together. Let's go backwards. Let's use team four, if you guys don't mind. And by the way, I hope when you guys are talking that you actually um, uh, figure out who's going to talk. So make sure whoever you decide your team speaker is, that they speak away. So here we are, and exercise here. So who's going to speak to this slide? Just unmute. Come on, guys, don't make me wait. Come
No,
on. Oh,
yeah, I got it.
We can't tell which. Okay.
sorry, my fault.
Yeah. So ours was a bit confusing because we had the hair trimmer.
Yes.
So it's not really data or anything being processed, but it's more just the removing of hair. So we said for our inputs, we just need the batteries, the charging wire, and charging capacity, and the actual physical blades. The activity that we're trying to accomplish is removing hair or trimming your hair, and then the output, the end result is your trimmed hair desire. But we kept it pretty simple because we weren't actually sure which direction to go with it.
Yeah, I think you need to add hair in here, right?
Oh,
I
and the
mean,
inputs.
as one of your inputs.
Okay. Well, yeah.
Just
So we were unsure whether to add the hair because it's not part of the actual. Well, I guess it's part of the system overall, but not the actual system
correct.
doing
So
the.
that's what I need you to think about beyond the system, right? What is impacting the system? What are you trying to do? You're trying to impact your environment. So
Right.
your environment is hair, right? Your activity is removing or trimming that hair. And of course, your output is hair removed, right? Or cut hair, right? Or something
Right.
like that.
Right.
So there are different ways to look at this. That's why I kind of wanted you to describe your concept that you did last week. Put that in here. that probably would have helped as you were working this. So, okay. Yeah, okay. Batteries, yeah, you need that to get the blades to work. Is that what you're thinking?
Yeah.
So function, you got your blades, you're charging it. Your charging wire is not an input, it's the actual thing that holds the energy, correct?
Yeah.
Yeah, so you just have to think about, is that an input or is that within the process itself? So this isn't, I don't want you to think, I want you to think functionally, not the parts. It's a functional aspect. So how's the charging wire part of the function? It's to get that energy, right? Does that make sense?
Yep.
Okay, good. All right, good, guys. All right, let's go to the next team here, team 3. Team 3, you're coming on. Let's see. Let's get you. I'll try to do the second page right away. There we go. All right, let me show detailed changes. All right, I think I can get rid of that. Okay, you ready?
Yeah.
Yeah, sorry about all these things. It shows the input. There we go. Go ahead, we're waiting for you.
Yeah. So all the inputs are a coffee cup, the flavored coffee which is inbuilt in the system. Then there is a hot water. Then there's a user input who selects the coffee, and there's a straw. Yeah. And then in the activities process, the activities go as follows. You just warm up the water, then select the process selects the flavor which was chosen by the user, and brewing takes place. I don't know if I should add the Fahrenheit, right? Fahrenheit. You just told me to specific, like, and then this straw out process, and then in the output, it just ejects the coffee in the cup.
I think the only activity is if you have this straw, I think you have to have your user put the straw. You do have, I think you had a user input here. There should be an activity for that. But your output's a warm, a hot cup of coffee, right?
Okay, yeah.
Yeah, no, that's good. Yeah, no, that's not bad. Yeah. And you may have an output of a straw.
I was actually gonna add something like, do you want any more coffee? An option like that. I was not sure.
No, I think it was a one cup deal. Right. And that was why it was important for you to describe your functional concept. Did you have that from the last class? Should have been exercise 2, right? I'm getting feedback from somebody. I don't know if my... Yeah, so here's your concept right here. So that would have helped you, right?
Yes.
Yeah, so. All right. The rest of your team, you work that as well. I'm getting feedback. Somebody must have their speaker in there. Let's get file 2. Team 2.
I'm speaking on that.
All right, good. Thank you for getting up early here. All right. And
So, yep, for team 2, we have the translator. So our inputs are going to be the voice input and from an outside source. Oh,
my fault. Nope. Oh my goodness. I lost you. Wait a minute. Sorry. I was fooling around.
No problem.
Microsoft Teams. Am I right? All right. It is the best way for you guys to talk, though. All right, go ahead.
Yep. So the outside source, which is the Google Translator database, our activities are going to be the recognizing of the voice from the database itself and translating the spoken voice into the desired output, the desired language output. And our output, of course, is the translated voice output.
Perfect. Yeah, no, that's really good.
Yep.
Now, if any other team from other teams see if there's anything missing, speak up. But this looks pretty good. Good job, guys. Good job. All right, and last but not least, team one. Let's look. You still in here. Notice your meeting now still on. You just have to hang up from that one. Anyway, just an idea. All right.
I'm here. I'll be speaking for our team.
All right. Open, edited teams. All right. Yeah, and you have the projector. Okay.
Yep. So this is Shadab. We had the projector for our interface. We had for our inputs. We had a user interface for the user being able to select what video they wanted to see. Storage. We would need for them to be able to have some type of video content to project.
Remember, this is functional, right? So
okay.
You mean file. It should be file. Right?
Yeah.
And I can't type. I don't know why I can't type. I'm like, why am I off? I can't type. Oh, well.
I can fix
maybe
it, but,
you guys can go in there. But yeah, the storage file, you meant file system, whatever you're projecting. Right?
Exactly. So, and then the activity would be the project video desired by user, and the output would be that 72-inch screen with HD resolution.
It's interesting. It's your activities like your output. But because your activity is to convert that file into your light mechanism, right? Whatever mechanism you're using, project. So you're kind of saying that by saying project, right? You're putting that function as part of that definition, correct? Yeah. And
that's what we were going for. It's kind of similar.
Yeah, and so your projecting is based on whatever your UI interface or volume rocker, whatever levels they're at, right? So your UI would pick the file. Hey, somebody changed it. I wonder why I couldn't change it. And yeah, so no, that makes sense. Very good job, guys. So the next time, if I have something like this, you can go to your previous slides and maybe cut and paste it in here and kind of give you the ability to look at that as you're working these processes. Good job, guys. Let's get right back. Any questions at all about what we're talking about here? All right, I'm going to go straight into it. I have so much to talk to you about, so I don't want to miss that. I am recording now. I apologize for not having that 1 hour of rambling. I converted it into 10 minutes of rambling. You're really going to have to look at the slides in order to catch up as we're doing this. All right, let's go right into the next process, which is CM, or configuration management. That's where you actually control and manage the system elements and configurations over the entire life cycle of the product you're trying to create. You manage your consistency between the products and its associated configuration definition. So configuration management is exactly what it says. You're trying to manage the configuration of whatever items that are part of your project. So notice over here, these configuration candidate configuration items can originate anywhere within the process. So this is, let me go back here. You'll notice that CM's down here. It goes all along the way. It's because you have things coming out of each of these processes that need to be configured. So for instance, you would have a preliminary life cycle concept. Those life cycle concepts will actually be worked out to be the final life cycles. Those would actually have to be under configuration control. The same with the various system functions. And notice you identify the functions, you define them, and you actually start developing your CM process would actually keep those. Same with architecture. So you'll see product and documents coming in. The other thing is, as you're actually trying to make the actual products or the pieces that make up the system, and then actually integrating them and going through the process of verifying and validating them. All those parts need to be under configuration control. So configuration management is the process of controlling where they are within the life cycle phases. So you plan, you perform the various management aspects, and also looking at status accounting and evaluating your configuration against what you said you would do. So your output would be your configuration baselines. If you're doing certain designs, you may actually have, after a technical review, a very specific baseline where you're at, and you would keep that baseline and you would add to it to get to another baseline. You would go like from a functional to your architecture baseline to your design to the actual as-is baseline. On top of that, you would have information management, very closely related down here to knowledge management, but from a project standpoint, keeping track of all the information that you would create within the project. You would actually, if you think about all these outputs that become inputs, and then more outputs, all those would have to somehow be managed. And so all this becomes information that you track and you keep up, and you have to figure out who has access to it. Is it the latest and greatest information? All that has to be taken into account as you prepare and actually perform your information management. And the main output is your repository, and you actually can see the repository. Right here is your information management. Your repository actually is provided to the project assessment and control process right here over the pack. All right. Now, your quality assurance is kind of quality management, but from a project project standpoint. Project quality management, of course, is from the organization standpoint. Quality assurance is from a project standpoint. Are they taking the quality management processes from the organization into the project? So you'll notice these guidelines and reports are all coming in from quality management, the organization. The activities allow you to come up with some reports to see how well you've done. So those are your all your processes that deal with project. Now we're going to get, and the last, now what I did is I went into the chapter 4, and there's the system analysis process. It was a new process, was added on version 3 of the handbook, and I didn't know what to do. I already had this diagram for version 3, and I had to modify it. But the more I looked at system analysis, it even says it's aids in decision making across the life cycle. So this system analysis is very similar to decision management. It goes across the whole life cycle, and it aids in the technical processes. So normally you have some kind of situation, just like you had a decision. This would be an analytical situation. You would prepare for that and then actually perform your analysis and then manage whatever analysis report that would come out. So this is a thing that goes all the way across. Now let's get into the V. On the left side of the V, you actually have business mission analysis. That's where you actually look at the mission, look at the solution space, determine your solution classes, and then you take and try to address that problem and take advantage of that opportunity. One of your main outputs of this, taking into account your strategy, source documents, as well as lifecycle constraints, one of your main outputs is your problem opportunity statement and your business or mission requirements. That's one of your main things that would be coming out of this. So prepare and define your space, characterize your solution space, evaluate your alternative classes, and then figure out, once you do your analysis, manage that analysis for the rest of the life cycle. From there, you actually start getting into a little bit deeper. That's where you start looking at stakeholders and what they need from the system. So the business would come up with perhaps some initial stakeholders, but when you get into this part of the process, you start doing an analysis of your other stakeholders and how they would impact the system. This is fairly complicated, as you can see, a lot of coming in from your business mission analysis. As you can see, it's quite extensive here. All of it goes into these activities, which includes preparing for doing this analysis and then defining those needs. We'll get into that in the next slide. But your main output here is your MOEs and your validation criteria, as well as your requirements. So you prepare your stakeholder needs and requirements, and then you define what those stakeholder needs are, come up with your requirements. Then you start developing your operational concepts or your ConOps, and you transform that stakeholder needs into stakeholder requirements, analyze those requirements, look for consistencies or inconsistencies, making sure they're clear and complete and consistent with each other. And then you actually come up with what those requirements definition is, and you actually manage those needs as you go forward. So these are your outputs. All right. So what I want to do is have you guys go back in to your, this will be the last exercise, and then I'll finish up the rest of the processes. But I want you to start thinking about the stakeholders that you would have for your function. Okay? Very easy to think that, okay, this function is used by these people that need the function, coffee addicts, they need the coffee and stuff. But there may be other processes, stakeholders involved. What about the coffee growers? Are they involved? How about regulatory for coffee quality and maintenance and stuff like that? Are countries worried about that? So you may have regulatory agencies. Are there enabling functions that you need to be aware of? What are those stakeholders? And are there future generations? So, and by the way, is there a stakeholder that may actually oppose the system? So you may want to think of that as well. So this shows you where your function would be in here. You would maybe have other operational functions you need to worry about, as well as your enabling systems and your various stakeholders. So, and by the way, your stakeholders should be based on your life cycle model, right? Because when you're in the engineering or development life cycle, you're worried about the acquirer and the suppliers and other things. Once you transform that to production or use, it now becomes your operators or your production system, or your actual quality control would be involved. What about logistics and maintenance or operations or disposal? All those life cycle stages would require different stakeholders in mind. So basically what I want you to think is, especially when you look at your diagram here, what are all my stakeholders from here on? Once I develop my system, what are my stakeholders when it comes to actually developing the software or hardware? What are the stakeholders for integration, for verification and validation, or my testers, right? What do I need stakeholder-wise from a transition? How am I getting this thing into the hands of the user? What about maintenance? What about disposal? All those need to come into play as you're thinking of your stakeholders. There are some pitfalls if you don't think about your stakeholder requirements, especially if you're thinking about people that are inside the system. You don't have that problem with the pomegranate, but if it's a larger system, a lot of times people forget that there are operators who actually have to touch and work the system in mind. A lot of times we forget that within the context of the system, there's a greater context that you're in, and you're putting data out into these other systems, and you got to take them into account. And don't forget external objects, and especially forgotten stakeholders like those who may actually not want your system to exist. What are their aspects that you may have to take into account, and may become a requirement to prevent those malicious actors from harming your system. We have some tips to help your customers get involved in your project. Identify who they are and actually get them involved. They don't need to be with you 100%, but they should participate in such a way that they will influence your project and make sure that they're happy with the system as you go forward. So what I want you to do is get back into your teams and start listing out your stakeholder for your functions. So just kind of 1 through 10 here, 1 through 8, you know, how many you can think of. If it's 3, it's 3. Also, when I get to your team, I'm going to ask how your team is holding up and how your project is coming along, your team project that you're doing for the CDR, especially coming up with your plan. So we'll talk a little bit about that. So let's go ahead and get into your teams. Let's try to finish it up by 6:15 or 6:20. I'll be able to, yeah, we'll start at 6:20, and I'll be able to finish up rather quickly and try to get you out of here a little before 7. So go ahead, get into your teams, and we'll get back together here in a little while, okay? Hey, Team 2, are you all there?
Yeah, we're here.
Yep.
Hey, guys, were you guys able to meet and go through the team folder like I asked in the announcement?
Yeah, we went through the project on Sunday night.
Yeah, and hopefully you went through the whole thing, including my CDR expectations with the 40 steps.
Right. Yep.
And what's important about that is one of the first things you need to do is actually come up with your. Let me share this. Come up with the actual. Sorry. When you're actually done, go into the general thing here for up here to general, and open up team assignment and fill out your FOI as you're up here. As you can see, team 3 already, they're going to do commercial vehicle operation. You know, they're not going to do the entire system. They're going to do a function of that system. So notice that even the example I gave you, I'm just doing parking, not the entire subsystem. So look at my example I gave you in core and you can see what I'm looking for. But it'll also give you a good sense of who has to do what in order to do well in the CDR, making sure you fulfill all my expectations. Okay?
Okay.
All right. Okay. Well, let me know. I just get a little worried because you guys aren't able to see each other or get together. Normally, when I finish my class, the teams get together because they're already there physically. You guys are going to have to make the extra effort to make sure you get together at other times. Okay.
And this is under general.
This file I'm showing you is under general. Yeah, right here. Let me show you. See right there, general files.
Okay.
Real straightforward. Okay.
Yep.
So that just fill that FOI out. Of course, almost everything is in the team's project. I need you to fill that out. And if you want to send me a note that says, here's our function of interest, that would be nice. I might ask you next week what it is. I would like that thing filled out. All right, let's see if everybody's in now. All right. Don't forget down here, yeah, I should move this up, but your CDR, I have all my expectations. And this is the use of core and going all the way down to showing a schedule. So I discuss how to actually design your FOI once you choose it. Okay. So this is pick your FOI. That's the next thing you need to do. All right, guys, I'll let you read this as a team.
Okay.
All right. Is everybody in? Let's see if everybody's in. Good. Everybody's back. Let's go ahead and start with team 4 again. Sorry, we'll switch it around next time, and see how their stakeholders. There we go. Okay, who's going to speak for team 4?
I can speak.
All right.
So we can get a chance to like iron them all out, but basically just the users, telephone providers, shaving razor companies, other individuals who don't want the product to succeed, so anyone who wants it to fail, essentially investors who are invested in the product and shareholders.
Oh yeah, that's a good one. Yeah. And shareholders, that's the same thing, I guess, right?
Well, all shareholders are stakeholders, but all stakeholders aren't shareholders. So shareholders,
yeah, I got you.
It could be like general public, like if the product does go, creates an IPO, it could be individuals like that. They do that.
So the only other thing, what is your concept that you have for repairing this thing? Would it be something that they would like just throw away and buy a new one or something? Or?
Oh, for repairing the razor.
The
portion?
razor aspect, yeah. And
Yeah,
could you,
that would be interesting.
so one of the things you may have is like if you build it in such a way. Why can't I have one of you can get in there and then? But the other thing is like your maintenance, or even if you have razors that you would exchange in there, right? Put new razors in. You may actually have to talk to razor manufacturers.
Yep, manufacturers.
Yeah, and actually the manufacturer of the phone itself would be one of the major stakeholders. Like, how do you actually build it? So you would have to talk to them about what processes they have in place to help you put the razor into the system. And what else would you be? What about this part of the life? What about this part over here? You see what that says? 414.
Yep, disposal.
Yeah. So would your landfill be a stakeholder?
I guess it would only go into disposal if the phone was being disposed, but because it would have to be applicable, I guess, and it had to be developed in a smart. So like
Yes.
that have interchangeable blades. That's what I would presume you'd have to accompany that. So I don't see how. The only case scenario I see the razor actually breaking is in if you design it right in rare cases, because my razor doesn't break. My shaving, the blades just go dull, and I just change the blades out. So
you would have blades, and those blades would have to be disposed of.
Yes. So we would have to. Yeah, that would have.
So you would have a stakeholder. Now here's the thing: if that blade winds up in the water, and my wonderful cow here drinks it and dies, is that cow owner a stakeholder?
Yes.
Okay. So that's the type of thing I want you guys to think about as you're working this, is kind of go beyond, like, what is the actual people that are touching this thing, even those who may not be using it, right? There may be other aspects. And you actually did a good job, the investors, shareholders, and even competitors. It's good to think of those. But there's aspects to actually building it where you get those stakeholders from the maintenance or even the disposal standpoint in mind. So that's where marketing may be another person, stakeholders that you get involved, because they may want you to develop it in such a way that it's appealing, right? So that's a requirement for you. So remember, your stakeholders are giving you requirements for how you're building your system. You guys are doing good. Let me get you to the next one. 3. Let's get you guys up. Team 3. Editing. All right. Okay, who's team 3?
I'll go. So the coffee manufacturers are one of the stakeholders, coffee bean farmers, coffee bean companies who convert the coffee bean into something edible. Then coffee product manufacturers like filters, straws, the packaging, everything in all that.
That little cute thing.
Yeah. Right. So operators, distributors who come in the logistics, the developing engineering, the engineers who design the pomegranate device and all. Then the shareholders of the pomegranate, and also in the forgotten stakeholders, competitors and coffee shop franchises who don't like our company to get succeeded.
Unless we can be like K, was it the K pods? And we would sell our little round things in Starbucks and stuff, right?
Yeah.
So we might be able to work them as positive stakeholders.
Okay. Yeah, sure.
But that's part of what you're doing here is you're coming up with your list, and then you start brainstorming. How can we utilize these people or modify, modify? You know, how can we, like Starbucks would love it if we sold Starbucks type coffee, right?
Yeah.
So I'm getting some feedback, Jay. Your speaker must be close to your mic, right? Something like that. All right. Let's go to team two. Sorry, team two.
Yeah, team 2 is here.
All right. Let's see. Open, edit in Teams. Second slide. Okay, what did you guys have?
Yeah, so our basic stakeholders are the external ones and the internal ones. The internal ones are going to be the owner of the pomegranates, the employees of the pomegranates, and the external ones are going to be the customers, the Google, which is going to be the input for the translators, our competing companies, and the government agencies. That's all. That's what we could have figured out at this point.
No, I mean, you may have, yeah, that's a good point. Government agencies, it may be, it's interesting. Do you know how many languages are in China?
There's probably a lot of languages in China.
Yeah, it's probably like the people from the north can't talk to the people in the south because it's not a dialect thing, it's a different language, right?
Right.
And so China's actually been really pushing a standard language. And so you could actually run into a government agency that is in charge of that language. And so your translation is important to them. I think France, isn't French the same way? They have like a committee or something to keep French from being devolving or something.
Right, exactly.
Yeah, so
even
those are the type of things you may run into as you're trying to work these. So that's good. That's good. The translation, the Google things. Now your function's more like you don't have parts and stuff like that. Just
right.
processor and stuff, but and the speaker, and of course the overall disposal of the phone itself is something you probably have to worry about. Now, when you say owner, you're talking about the pomegranate company, right?
Right, the pomegranate as a whole.
Gotcha. Yeah, and of course, employees would be the developers, the marketing,
the operators. Right, exactly.
Yeah, that makes sense. All right, good. That was good. Okay, and that's team two, right? All right, last but not least, and we'll get you guys out of here. I want to be late again. All right, who's going to speak for team one?
I will.
All right, good. Precious. All right.
All right, so for our stakeholders, we have the users and the customers as the external stakeholders, and the shareholders is the external stakeholders as well. So for the internal stakeholders would be considered the design engineering, development, production process, logistics, maintenance, and all of that. And then we would also consider the users when it comes to disposal and parts recycling would be the users as well.
Okay, so you're the video person, right? People?
Yes.
So one of the things you'll either be opposed to you or you can get them on board is what? Do you remember the second thing they said you could do a meeting presentation, but what was that lovely couple on the couch watching? Remember? Wow, did you guys watch the video of the pomegranate? I'm losing you.
Yeah.
So what were they watching? In beautiful HD. Come on, guys. Hold on.
Movie, I think.
It was a movie. And who makes movies? Come on, they don't come out of nowhere.
The movie industry.
There you go.
Hollywood.
Yeah, I'm waiting for you guys to talk. You guys are like, oh, it's so obvious, but you need to talk
Okay.
because I can't see you. So, movie industry. So, what does the movie industry worry about? This type of stuff, right?
Sales.
Well, yeah. Remember what happened with the VHS and even DVDs? And so the movie industry started really trying to do things to either prevent them or somehow modify it. So that's a stakeholder that actually may impact the way you design your system. Because what if they come back to you and say, no, you need to put in some kind of managing the actual, if somebody buys it, what do you call it when you buy something, you own it? And
Copyright.
yeah, some kind of copyright infringement capability, so that you may actually have to, look at the standards that they're throwing at you. So that could be a stakeholder, somebody who's has standards that prevent you from presenting or projecting certain things. But now you did a good job of listing the major ones. It's those type of hidden ones that may actually work. The other thing is, could you use your video projector as a weapon? You're all on mute, by the way, if you're talking.
For what do you mean? Could it be used as a weapon?
Okay, how much lumens are coming out of this device? And if you stick it in somebody's face, what would happen to them?
Right.
So I'm just saying we need to think all the way through, like how it even would be misused, and are there aspects you need to take into account to work that.
Okay.
Make sense?
Yeah, we'll account for that as well.
All right. So anyway, that's what's interesting about this pomegranate. It's such a ridiculous product, but there are aspects to it that you probably need to think through as you're trying. And that's what I'm trying to get you guys to do, is really think, especially when it comes to your mission and the way a lot of systems, it's not so much they're misused, but a customer or user can reuse your system for something else. And to get ahead of that will really help you a long way in making sure that it's working properly. All right, and that nothing will happen as a surprise. All right, any questions out of this? All right, look, I'm going to finish up real quick. I am recording this, so you should be able to watch it later if you run in things. But we're going to just speed through this. I'll get you out of here a little before 7 o'clock. I'll hang around, especially if as a team you want to talk to me or something like that. I'll hang around here after everybody else hangs up. I'll still be here. All right. After you do your stakeholder requirements, now you have to go ahead and transform those stakeholder user-oriented view into a desired capability from a technical view of the solution that meets that operational need of the user. So really the stakeholders are kind of, here's the functions I want. The system requirements take those functions and actually incorporate them into the real world. How do we get that to work? So part of that is getting that all that information from the stakeholder needs requirements and actually start working and analyzing those requirements so you can come up with your major output here is your system requirements as you're doing it. So let's look at this a little closer. It's right here. System requirements, you're after your stakeholder before your architecture definition. Notice your RVTM comes out and actually informs your verification as you're doing that. And one of the major outputs here is also your MOP. So up here, your stakeholder needs actually gave your measures of effectiveness or your mission understanding measurements. Your MOP looks at the system as a whole, and that comes about when you understand the system as a whole, and that's where the requirements come in as a system. So the other, so that's your main output is your actual MOP and your system requirements, and your RVTM, which is your requirements verification traceability matrix, is actually updated. So you have your requirements and you're tracing them all the way through this process. Your next thing is your architecture. That's where you actually generate alternatives for your architecture. So you would have your system, this system I want to build, but all those parts necessary to build that system and get those emergent properties you're interested in. Well, you can have many and varied parts, right? This part and this part could be one big part, or it could be a slightly bigger part, smaller part. You can go ahead and create quite a different type of architecture, and different alternatives will get you different results of what you're looking for. So remember, you're looking for these alternatives that can actually take into account the stakeholder concerns, meet those system requirements, and actually express the architecture in a set of consistent views. So of course, all your inputs would be your system requirements, as well as information from your life cycle concepts. You prepare and develop the various models. Then you relate those architectures to the design that you have previous, and you actually assess which architecture is the best. So once you say, here's the architecture I want to go with, you manage that. So your main output here is your architecture description. So these are your inputs. You prepare, develop, and then you do this trade analysis of the various candidate architectures in relationship to the design. After that, you do your design definition. Now you have your architecture. You have enough detail to now figure out what it takes to implement those elements. Well, some of those elements are fairly complicated. And guess what? You wind up with figuring out alternative elements that would actually meet those requirements. And you would maybe have to do a trade study in that regard. But you want to get to the point where you actually come out with the implementation that's consistent with whatever the architecture is, as well as the model and views of the system in accordance to the architecture. So your main output here is your system design description, but your system element descriptions as well. And notice here that we now have designed your technical performance measures now are one of your main output here. So stakeholder needs gives you your MOEs, system requirements gives you your MOPs, and your design definition gives you your technical performance needs. All right. All right. So after you're done with that, you now have enough information to go ahead and create the actual system elements based on the actual system description and rationale that you've been given. So you actually prepare and perform and manage the implementation, and your output, it will be actually these system elements. Notice in red, I actually put in kind of the final, everything you work towards to get to this point, the actual physical manifestation. So your system elements is coming out from you actually creating those elements, or you actually go in and acquire those elements. Remember what we talked about Boeing and having needing an airplane engine. So they went to Pratt and Whitney. Well, they acquired something, and lo and behold, that accepted engine is now part of the elements that were created, the frame of the engine, of the airplane and all, and they all come together. And that leads you to the next process, which is your integration. And that's where you synthesize your set of system elements and actually create the system that actually satisfies all the requirements, architectures, and design that you did previously. So integration is creating that actual system. So you can see it here. When you're done with actually creating that system, you have an integrated system or system element, and that feeds into your verification. So once you go through this process, you now go into verification, and that's where you actually get evidence that you are actually have systems or system elements that fulfill whatever the requirements or characteristics are. And you actually can see that when your inputs are your system requirements. So if you look over here, your system requirements and verification criteria and requirements verification traceability matrix all flow into this verification process. You're basically taking the system as a whole and looking at the system and testing it, verifying it, demonstrating, analyzing it, whatever process you use or technique or method, you verify to make sure it meets whatever your system requirements are. And notice that one of your outputs of this is your actual verified system. It's coming out of this. You can see it here too, verified system. It's working. All right. So out of that, you now get to the point where you actually transition it. In other words, you actually take the system that you said you would build for someone and you put them into the operational environment. So in other words, you take it, pack it up, and you put it into the environment that the user's expecting. It's at this point your trained operators come into play, even though you did that previous, but that now they're actually going to be used as you're doing this. So you prepare and perform once you get your verified system and you come up with an installed system, and you can see it right here, verified. You perform the transition, get it into its environment, then install it. Now, once that happens, you have to figure out, will it perform the mission? That's the next aspect here. And that's where validation comes in. Will it fulfill your mission objectives in the stakeholder requirements, achieving its intended use at its intended environment? So this is where, if you guys are DoD, you know what OT&E is. It's the operational testing and evaluation. That's what this is, validation. So from in COSI and most system engineers throughout the world, they talk about this as a validation technique that you use to verify, to validate that the system will perform the mission that it was supposed to. As a matter of fact, when you look over here at validation, notice that the stakeholder requirements and validation criteria are an important input into your validation of your system. Once you go through whatever you do, mostly demonstrate it, you will have a validated system. It will perform the mission as you go forward. So with that in mind, you wind up putting it into operation. So you actually use the system to deliver the service that you expect it to do. You also, at the same time, go into maintenance mode. So that's where you actually make sure the system works as you're going through it. Eventually, you get tired of it and you go into a phase I call, it's not you, it's me. So you want to break up with the system. Well, you want to actually perform this disposal. So out of your operation and maintenance, your validated system will actually go into the disposal thing. And actually, one of the main outputs of your disposal, as you look into it, you're actually retiring the system, is an actual disposed system, if that's the case. Now, remember, you're also trying to end its existence. So there may be no disposal system. You got rid of everything. But that's part of why I wanted you to think about these processes, what stakeholders are involved in the disposal. If it's a disposal that will hurt some cow in the future on a farm, then yeah, you need to worry about the disposal, and that farmer is a stakeholder. All right, and that's it. It's good to think about, like, where are you in this vast machinery of system engineering? When I look at where I am, I've been in almost all these, but you may find yourself deep into like requirements or architecture design, or even in the testing, be it verification or validation, or maybe you're helping out with CM or risk management. No matter where you're at, somehow you're involved in this vast organization, and you actually should understand the context of the job you do in relationship to everything. All right. So with that in mind, I'll leave the mics open for you. If you have any questions, please try to do your read ahead. A few of you have not submitted your quizzes. You did your quiz, but it's kind of stuck in there. If you find that you can't submit it, just let me know it's done. I'll go ahead and grade whatever it is, wherever it's at. But do try to get it into a submission mode. Don't forget your homework is due next week. If you have any questions on that, let me know. And you need to start, talk to all your teams. You should be getting together and actually working together through that team folder. I have various things in the folder, especially the CDR folder. It explains to you what needs to be done to have a successful CDR. Please don't ignore that. Go through it in detail. It should help you be successful. And also figure out who does what. Very important for the plan for who does what, because you don't want to do a CDR and all of a sudden you have an empty hole because somebody didn't know they were supposed to do it. So make sure you meet all my expectations for CDR. This is homework by the numbers. You should have, you'll have 3 quizzes by next week, and your homework will be done. Slowly but surely, we'll be adding to this the tests and the team presentation. So be sure to stay involved and keep involved with Blackboard and everything I put in there for you. All right. Next week, we'll talk requirements. Now, you may wonder, requirements, we already did that. When we're doing system implementation integration, you kind of need requirements and understand requirements in order to make sure your implementation's right. So I'm going to get into requirements one more time. And these are my references. So that's it. We're done. So I'm going to let you guys go. If you guys want to stay a little longer to talk about anything, I'll be here. And but other than that, we'll just go ahead and call it a day. Okay?
Hey, Professor, I have one quick question. When people
Please ask away.
So the homework, the 3 MOEs, that's what's due next week, not tonight.
Yeah, remember I put all that in my spreadsheet on one of my. So go into Blackboard when you get a chance, and go on up to the syllabus, and you'll be able to see not the syllabus, the welcome. I think it's in the welcome.
Yeah, it's like the little
scope and sequence says when things are due.
Yeah, I was looking at that. I just got a little confused.
Nah, I'm sorry. Well, do your best. Yeah, if it keeps getting confused, let me know how I can change it.
Okay, thank you.
Yeah, I really appreciate it. But right here it says for requirements, homework 1, 2.
Okay,
All
cool.
right. Any other questions?
Yeah, it says due week 3. So I went to the other folder and I turned in the mission analysis of ABS CS. That was homework 1 for individual, I guess.
Yes, that's right.
That was due today, correct?
No,
Oh, okay.
I'm showing you the scope and sequence, right?
Okay.
You guys have to, I try to, and I apologize for not letting, I
'Cause
give
it
you as
says
much.
it says week 3, and I
Yeah.
thought that was week 3 because
Oh, no, Labor Day is here. Right?
oh, 'cause this is week 2 technically.
Correct.
I guess. Okay.
Class, right.
Okay, got you.
No, that's a good point. Yeah, I can see you being confused on that. Remember, this is the AVCS, which is different than your team project, right? Your assignments are for your as individuals, and in there you should be going to class references and going to the IVHS. This is all you should be looking at. Now, when you do your team project, you actually have your specs here for the team. It has nothing to do with your individual assignment. You understand?
For the
Everybody,
for the
guys
team
get ready.
project, Professor,
Professor.
are there like 4 or 3 people in my group because it's a little bit confusing?
You should not be doing homeworks with your classmates. Your
No, I
home,
meant for the team project.
yes, team project. Go ahead.
Yeah, so I was asking if there was 4 or 3 people in my group because the where you have it is a little bit confusing. So we have 4 and then it says I only see 3 names. So I'm trying to figure out like how do we break down work amongst ourselves if there is 3 or 4 people. So I just wanted to make sure how many people are indeed in my group.
So did you go into this folder here?
Yeah.
And do you see your names of your members?
Yeah, so
Why
Jeff
is
is
that?
not on there, so I'm just trying to make sure.
It's right here,
All
and
right.
it's also down here, and it's also in your team project up here, your team members.
All right, so there is 3, not 4. All right.
I don't believe we may have had 4 at one point, but a few people dropped out. I had to rearrange.
All right.
But you again, if you get together as a team, the 3 of you, you should be able to figure out who should do what. There should be just one person figuring out, right? So you guys should work together, figure out who should do what. That's the importance of you guys getting together as a team, so you guys can kind of, even though it's virtually, meet face to face, right? Right, Precious?
Yeah. Thank you, Professor.
No problem.
Professor, one more quick question. For
Please.
the homework, there's 2 it says what is the overall operational success criteria. Do you want the success criteria or do you want us to develop measures of effectiveness? Because those are a little bit different. They're different. The success criteria, the MOEs are derived from kind of success criteria, so to speak. So I don't know what kind of like format you want.
I show it here, right? Is this confusing, this example?
So I got that, but then when I open up the homework, I know what an MOE is. It's just when I open up the homework, it doesn't ask for an MOE. It asks for it says measures of effectiveness up top, but then it says what is the overall operational success criteria.
I don't.
Not MOE. Those are success. Those are like improved safety by reducing annual injuries by 8% in 2011. I mean, I guess that is a measure of effectiveness.
That's correct, right?
Yeah, that is. Okay.
Yeah,
right.
I was confused because MOEs are operational success criteria.
They are. Yeah, okay.
And by the way, guys, when you're doing this, don't think about something that is too long term. I've had people put in MOEs like the ATMS will, not kill people for 8 years. So how would you verify that? Well, I would look at it for 8 years. No, can't look at something for 8 years. So your verification method has to be kind of, you kind of have to do a verification method that makes sense from a time frame. Like, how are you going to accept this, right? You can't be having this system up and running for 2 years before you accept it. So there has to be a verification method that makes sense in order for you to accept it. And so you may only have 6 months to accept it. So what would you do if you only had that much time? So when you think of your verification method, think in those terms. Does that make sense? All right, now I probably gave you too much. I wanted you guys to fail in that respect. I would let you know, but anyway.
Also, I read the homework papers, and I thought you wanted the years from the homework papers, so my years are outdated. Just wanted to say that. If you want me to resubmit, I can update the year.
No, the years don't matter. It's the success criteria that matter.
Okay, thank you.
But it really, actually, you shouldn't have years. You should have a time frame. You should say, is it a year?
Like
Is it
by
6 months?
2011, what I was doing, like by 2008.
Yeah, just say within a year. You don't have to put an actual date.
Do you want me to resubmit and update? Because I didn't say.
No, as long as it makes sense, you should be fine. You can look at it. I'm not going to grade them until everybody up, Jay. So you can resubmit. You can do that.
Okay, thank you.
I mean, it's totally up to you. But oh, by the way, you can resubmit as many times as you want. I'm only going to look at the last one you submit. The others I'll probably delete. So.
Awesome.
All right. Okay, the class is over. So if you guys wanted to hang up, you guys can do that. So. But I'll stay for anybody who wants to talk anymore. So.